have, we'll do a little bit of together stuff tomorrow at the beginning of class, but then you should get a little bit of time in class to work on your review. So any questions that you're worried about, you can do those first in terms of the work time we have tomorrow. Okay, so here's the first one we're going to do. Oops, not Pam.
Just doing more problems.
Yep. Like I said yesterday, we just got to be able to get comfortable with different types of problems that we could come across. You're not comfortable? Okay, so first of all, do we have a product? Okay. Technically, 2 is being multiplied to tangent, blah, 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 blah. But since 2 is a constant, we don't treat it like a product rule. We just know that when we take our derivative, it's going to be 2 times whatever the derivative is. When you have a constant multiplied out front, it just goes along for the ride. Okay? Don't have to worry about the product rule because you know that the derivative of 2 is 0. That's not good. Okay? All right. What is our outside function? The cube. Okay? Tangent is inside of the cube. Right? So the first thing we need to do is take the derivative of whatever cube. Okay? And if I have something cubed, we do the power rule. So 3 times tangent squared. Okay? Now, we've done the power rule. What is inside our power? What's inside our power?
Another power.
What is inside of our power? Tangent is inside of our power. So when we take the derivative of the inside, right, we now need to take the derivative of tangent. But then there's something inside of tangent, isn't there? So now, chain rule again, we need to take the derivative of what was inside of tangent. Okay, ask me a question. What can I help you process through? Yeah, and we can make it look prettier, but that's it. Our outer function was a power. We did the power rule and left everything the same. Inside of our power was tangent. We took the derivative of tangent, leaving the inside alone. Inside of tangent was this polynomial. We took the derivative of the polynomial.
How come just like the cube alone is the outside function because the x plus 2 squared is inside quantity?
Right.
Inside.
So since this cube is floating with tangent, it really means like the tangent cube. Like the tangent function itself is being cubed. Anytime you have that floating exponent with a trig function, it's really just saying that whole function is being cubed.
So
That's just where they put it.
we can change it to that.
Yes, you are welcome to change it to that if that helps. And we could make this look prettier by saying 2 times 2 is 4 times 3 is 12 times x plus 2 times tangent squared of the inside times secant squared of the inside. But it's okay if you don't. And when we get to unit 3, we would want to do that. But right now, that's not a requirement I'm giving you. All right, should we try another one?
Sorry.
That's okay.
I don't understand the end. Like, because the tangent cube, like I understand the derivative of the tangent, the secant, but then how do you get the thing on
So inside we have a polynomial. So I took the derivative of tangent, leaving the inside alone. But then we have another function inside that we need to take the derivative of. Like we had a polynomial inside of tangent, and so we had to take the derivative of that polynomial for the tangent.
So you basically go until you run out of powers inside.
You go until you run out of functions to take derivatives of, yes. Okay,
Can't you take the derivative of that
what would it be?
one?
Yeah. And that's unnecessary. Okay, Max.
So it's like, it's fine to have like secant squared, you don't have to do the power rule of that or anything.
No, because that's the derivative of tangent is secant squared.
And then having tangent squared is, okay, yeah, I guess easier to do the derivative.
I know, we just kind of gotta like process through. Okay. All right. Braden thinks we need more practice with trig. Right?
That's the
Where is this square?
inside cosine.
It is inside cosine. We have a quadratic, technically, inside of cosine. Do you see the difference for where that square is compared to the first one? Okay. So our outermost function would be cosine. And inside of cosine, we have a composition with a power. Okay. So our derivative, our outer function is cosine. The derivative of cosine is, ooh, good job, negative sign. Leaving the inside alone. Then our inside is this right here. We have a composition where we need to worry about what rule first? The power rule. You don't have to write the one, I'm just doing it for dramatic effect. Okay. And then inside of that, we have this. And what is the inside derivative? Negative 2. Okay. So if we wanted to make it look prettier, we would have 4 times 1 minus 2x times the sine of 1 minus 2x squared. That would be a way to make it look prettier, but you don't have to. No, because we have negative 2 times positive 2 times this negative up here. Okay. Deep breath. Okay. Gonna do your question.
Oh, yeah, negatives.
Just keep it off. Okay, we can come in. Okay, at your pod. How much you work on this one?
No, you can change.
You can change it to x to the negative 1/2. So then we can put that
Negative 1/2
is
x.
negative 1/2. X to the It's a t-shirt. It's one half x to the negative 3x. Yeah, that's done. So 2 times 1 is 1 minus x to the negative 1/2 times 1/2 x to the negative 3/2.
So trying to screw it into negative x.
Well, this would be a negative though, right?
I like the idea. Well, it's minus here.
Oh, yeah. You're right. Sorry. That wasn't that.
Yeah, it was only confusing.
Okay. Before you start taking this derivative, what would be the best thing to either do or think about mentally? Okay, you want this to be x to the negative 1/2. And I'm really flexible. If you want to think about that mentally, I have no problem. Some of you are going to want to write it out. Some of you are just going to think about it. Okay? But when we take the derivative, okay, Courtney, talk us through how your table did it.
Okay. So slap the two in front. It's to the first now, so the
Okay.
and then times the derivative of the inside, so we just did 1/2 x to the negative 3.
All right, this is pod 1's derivative. Do you agree? Good. Okay. We have about 10 minutes left. And in my opinion, no, sorry. I was thinking about 45 and not 40. Okay? I'm going to put 2 problems on the next slide. And I want you guys to work together at your table to do the 2 problems. And then we'll go over the answers and call it a day. Okay? Okay.
I sound the most. Let's go. I keep getting stuck to my tongue. It's like an extension.
Together.
Yes.
Okay, the derivative of sine is just cosine.
That one, you start with all that product, one, all of that in one.
Okay. So you need to do your second. You need to keep. Like when you do the power rule, it's 5 sine squared.
That's actually.
Then you can work on the derivative. You get the derivative of two functions.
Okay.
So, yeah.
Okay. Sine is the one being close. So when you take the power rule derivative,
Well, now we have to
it's
take the
5
derivative
times
of that.
3 of sine squared.
So it doesn't, and then it turns
Then after that, you take the derivative of sine.
it's,
I got it already.
The derivative of sine is normal cosine, not cosine squared.
I'm not sure.
The only reason you have to replace
It's my house now. You gotta figure out.
besides the actual.
Yeah, I thought.
I figured out.
That is not cosine squared.
2x inside secant
The
4x.
derivative of sine is cosine. No. No, x squared plus 1 starts in outside of that. I really gave you a.
And then.
So I'm saying, why doesn't the two, so no matter what, the exponent, it's like, it never goes over.
No, the only reason why it looked like that last time is because the derivative of tangent is secant
Yeah.
squared. Yeah.
But it just,
It's just the derivative of whatever is inside of that power.
you just forget about the exponent when you're taking the derivative of that.
Mm-hmm. Yep. So here should be your first derivative. And then I think let's just talk about the second one real quick because we have like 40 seconds left. What kind of, thank you for reading my mind. So the derivative of secant of 2 theta. Derivative of secant is secant, oh man. Times 2 times the second plus the first times the derivative of the second would be secant squared times 4.
Oh, you just had that in?
Because it's a chain rule. Since you have 4 theta inside, we have to multiply by 4.
Oh.
Since we have 2 theta inside, we have to multiply by 2. Yep. Hey, that is what matters, Brayden. Okay? Sorry that I got closer to the bell than I anticipated. But... Okay, do your homework. Review day tomorrow, Isabel.
You said that you're gonna be here till 7:30, but tomorrow's Wednesday, which is 7:30.
Thursday, I'm going.